Welcome to The Explainer. Today, we are diving into a pretty radical new idea in education. It borrows a concept from the absolute strangest corner of science to ask a fascinating question. What can the bizarre world of quantum physics teach us about unlocking a student's true potential? So, it all starts with a question that, let's be honest, sounds a little bit crazy. What on earth could a subatomic particle possibly have to do with a student in a classroom? Well, as it turns out, maybe everything. Okay, to really get this, we need to wrap our heads around a core quantum idea called superposition. In the quantum world, before you actually look at a particle, it doesn't have one single identity. It's more like a cloud of probability, existing in all of its possible states at the exact same time. It's only when you measure it, when you look, that that whole cloud collapses into a single, definite reality. Now, here's where it gets really interesting. What if we took that exact same idea and applied it not just to particles, but to people, and specifically to students? Think about it. The traditional view, it often slaps a fixed label on a student. You are good at math, or you are bad at science. But the quantum view sees a student in superposition, a field of infinite possibilities. They are brilliant and searching, creative and analytical, all at the same time. Every potential outcome exists within them at once. So, this brings us to a really crucial point. If a student is this beautiful, complex cloud of potential, what happens when we try to measure that potential with, say, a traditional test? That test, that grade, it acts like a hard measurement. It takes that incredible wave of potential and collapses it into a single limiting reality. The student who could be anything suddenly is just one thing, a C student. And just like that, the possibilities vanish, replaced by a label. The entire goal of quantum education, then, is to keep that potential waving. It's about nurturing the process of growth and exploration, instead of rushing to measure an endpoint and collapsing all those other incredible possibilities. But what does this actually look like in a real classroom? Let's see it in action with a biology lesson on something we all think we understand, the human heart. Instead of starting with some dry definition, the lesson kicks off with a mystery. The question itself frames the heart not as one single thing, but as something that exists in a superposition of states. It's a mechanical pump, it's an electrical circuit, and it's a chemical factory all at the same time. So the class is then broken up into 4 groups, and each group is given a totally different lens to observe the heart with. They're all studying the same organ, but from 4 completely different, simultaneous perspectives or states. It's so cool because each group explores a completely different yet equally valid reality of the heart. The plumbers, they only see the mechanical flow. Meanwhile, the electricians are completely ignoring the blood. They're just focused on the invisible electrical signals that drive the whole system. And then comes the moment of synthesis. You could call it the moment of measurement. A real-world scenario is introduced that forces every single person to see how these seemingly separate systems are actually one deeply interconnected whole. This question is so powerful because it makes all these abstract ideas intensely personal and immediate. It forces the students to apply their specialized knowledge to a single, chaotic, real-world moment. And this is what brilliantly illustrates the collapse. The students suddenly see it all happen at once. The psychologists signal the fear, the chemists release the adrenaline, the electricians fire the signals, and the plumbers pump harder. The heart's true nature is only really understood when all of its states are viewed working together. But this creates a huge challenge, right? If a standard test, that hard measurement, crushes this complex, nuanced understanding, how do we possibly assess learning without destroying it in the process? Well, the answer comes from a concept in quantum physics called a weak measurement. Instead of forcing a single outcome, it gently gathers information about the entire system without causing it to collapse. It's all about assessing a student's ability to navigate complexity, not just spit back isolated facts. So here's the first example. Instead of just asking for a simple definition, you present a really complex case study that requires thinking across multiple dimensions all at once. This question makes it absolutely impossible to give a simple, one-dimensional answer. It forces the student to synthesize their knowledge from the plumber, electrician, and chemist perspectives. You see, this isn't just about the heart anymore. It's about training the brain to see the world as a series of interconnected systems, which is an absolutely essential skill for solving complex, real-world problems.
Here's another really powerful method. You introduce a hypothetical problem, a what-if scenario, and you ask the student to predict the consequences across the entire system.
Now, this kind of question tests for truly deep comprehension. It's not about repeating facts, it's about proving you understand the critical dependencies between the heart's different states. Can you predict the ripple effects? This encourages creative problem solving and predictive thinking, moving far, far beyond simple memorization. Finally, the feedback itself has got to change. It shifts away from a rigid judgment, that final collapsing measurement, to a more collaborative observation, one that keeps the student's potential in focus. With this kind of feedback, a student hasn't failed. Part of their understanding is simply still developing. It's still in a state of potential, a cloud of probability. The goal is to sharpen the connections, not to label the result. This builds resilience. It teaches students that learning is a continuous process, not some final verdict. And this leaves us with a profound challenge, doesn't it? A challenge to the very foundation of education. What could we achieve if we just stopped collapsing potential with labels and grades, and instead we learned to see and nurture the infinite possibilities that exist within every single learner?